This is one question taken from NCERT, class 9, surface area volume. It says that the radius of a spherical balloon increases from 7 to 14 centimeter. Right. Initially, it was 7 centimeter. Now it increases to 14 centimeter as the air is being pumped in it. We have to find in the first part the ratio of surface area of the balloon in the two cases, and similarly the ratio of the balloon, that is the ratio of the volume of the balloon in the second case. So what we have, let's say if I make one sphere, let's say this be the balloon, and if I make a copy of it, let's say I made a copy of it. Now, in the next case, what is happening? Its radius is increasing. Its radius is increasing, and now its radius is 14 centimeter. So the initial radius, that in the first case, that is the radius here is given R as 7 centimeter. And in the next case, the radius, which I'm using capital R, as 14 centimeter. So in the first part, we have to find the ratio of their surface area. So we can write, say, S be the first case, like S be the surface area of this, and let's say S dash is the surface area of this. So we can say S over S dash. This surface area, I can replace it with its formula, the surface area of a balloon. By formula, it is 4 pi r square, that is, as it is spherical in nature. And similarly, we can find we can write the surface area of this second, that is S dash, it is 4 pi r square. Now, notice I have used capital R here for this bigger and small r here for the smaller one. Now, what we can do next here, we can reduce this. As we can see here, 4 pi and 4 pi get cancelled. So we get S over S dash is equal to small r over capital R whole square. So finally, we can say S over S dash is equal to R over R. That means we can replace small r with 7 and capital R with 14, and we have to get a square of it. Before finding the square, we can reduce it 7 one times, 7 two times. So that means here S over S dash is equal to square of 1 over 2. That means 1 over 4. So we can say that the required ratio here is 1:4. So in the first part, we got this answer, and the required ratio is 1:4. Now, similarly, in the next part, we have to get the ratio of their volume. So let V be the volume of this and V dash as the volume of the other part. So V over V dash, I'm replacing V with its formula, that is 4 by 3 pi r cube, that is the volume of a sphere. Similarly, I can write V dash as 4 by 3 pi capital R cube. Why capital R? Because the volume of this bigger sphere is 14. Now we can reduce this. As you can see, 4 by 3, 4 by 3, even pi get cancelled. So we get V over V dash as small r over capital R whole cube. This is again V over V dash. I can replace small v with its value, that is 7, and capital R with its value, that is 14 in this case, and then cube of this. So I can reduce it similar to the previous question. It is 1 over 2. So we can say that V over V dash is 1 by 2, the cube of 1 by 2, right? As cube of 1 is 1, cube of 2 is 8. So we can say that this time the ratio, that is V over V dash, will be 1:8. So the new volume, we can say that by increasing the, as you can see here, by doubling, we can also conclude that by doubling the radius, the volume becomes 8 times. And similarly, by doubling the radius, we get the surface area as increases by 4 times.